Hello friends. This video is brought to you by mywayteaching.com.
Let us now look at another method of finding the roots of a quadratic equation by completing the square. Consider the equation x square minus 9 equal to 0. Now this is a quadratic equation and we have to find the roots of this equation. This one can be solved as x square equal to 9, x equal to under root of 9. So x can take values plus 3 and minus 3. Now consider another equation x plus 2 whole square minus 9 equal to 0. This is a quadratic equation and to solve it we can write it as x plus 2 whole square equal to 9. This gives us x plus 2 equal to under root of 9 or x plus 2 equal to plus 3 and x plus 2 equal to minus 3. Further solving we can get x equal to 3 minus 2, that is 1, and x equal to minus 3 minus 2, that is equal to minus 5. So we can see in both the cases we could find the roots easily by taking the square root. But what happens if we are asked to solve the equation x square plus 4x minus 5 equal to 0? In this case, we would probably apply factorization to find the roots. But there is another method of solving this equation. We can write it in the form of x plus a whole square minus b square equal to 0. And we have seen that it is easy to find the roots of quadratic equation of this form. In fact, we can convert any quadratic equation into this form. So let us see how we can convert it, and this is called method of completing the square. In this method, we want to convert the x terms into a perfect square. For that purpose, our process goes like this. We divide the coefficient of x by 2 so that we can write it as 4 by 2x plus 4 by 2x minus 5 equal to 0. Note here, by dividing by 2, we are not changing the equation because this becomes 2x plus 2x, which is 4x. So now our equation looks like this. Now, from the first two terms, we can take out x common and get x plus 2 in the bracket. Rest of the equation remains same. We want to convert this into a perfect square. What should be added to 2x so that I can take out something common and get x plus 2 in the bracket? If I add 2 and take out 2 common, I get x plus 1 in the bracket. But I want x plus 2. So, if I add 2x plus 4 and take out 2 common, I can get x plus 2. That means addition of 4 can give me x plus 2. But I cannot add anything in the equation. If I do so, then I have to subtract it. That means we rearrange our equation as x into x plus 2 plus 2x plus 4 minus 5 equal to 0. Addition and subtraction of 4 has not changed my equation, but it has facilitated us, as now we can take out 2 common and get x into x plus 2 plus 2 common x plus 2, and minus 4 minus 5 becomes minus 9 equal to 0. From the first two terms, we get x plus 2 common and x plus 2 remains in the bracket, which can be written as x plus 2 whole square minus 9 equal to 0. So, our purpose is solved as we have converted the x terms into the perfect square. And now we can solve this as we have done earlier. This can be written as x plus 2 whole square equal to 9, and x plus 2 will take values plus 3 and minus 3, which will give us x equal to 1 and x equal to minus 5. Let us consider another example and say we choose to solve this quadratic equation by method of completing the square. How we will do it? We firstly see that the coefficient of x square is not a perfect square. So what we can do is multiply the whole equation by 3 so that the coefficient of x square becomes a perfect square. This gives us 9x square minus 15x plus 6 equal to 0. Now this is an equivalent equation of the given equation, and the solution of 9x square minus 15x plus 6 equal to 0 will also be the solution of 3x square minus 5x plus 2 equal to 0. Now let us look at how we can make the x terms into a perfect square. We have already introduced one of the methods. Let us do this question by another method. We can write 9x square as 3x whole square. Let us recall the formula a minus b whole square is given by a square minus 2ab plus b square. If we consider our a equal to 3x, let us see how can we split 15x as 2ab. For that, I start with 2. My a is 3x, but I want to get 15x. What I do is divide 15x by 2 into 3x, which will give me 5 by 2 as the required b. See, if I take b as 5 by 2, which I have calculated, the value doesn't change. 2 gets cancelled and we are left with 15x. So, now I have my b as 5 by 2 and I need to add b square and subtract b square to convert it into perfect square. So let us add b square and subtract b square to convert this equation into a perfect square. This helps me to convert the x terms into perfect square. and we are left with 25 by 4 plus 6 as the constant term. Solving the constant term, we get 1 by 4. Now further we can solve this as 3x minus 5 by 2 will be equal to under root of 1 by 4, which would imply that 3x minus 5 by 2 equal to plus 1 by 2 and 3x minus 5 by 2 equal to minus 1 by 2. Solving these two linear equations, we can get x equal to 1 and x equal to 2 by 3 as the roots of the given quadratic equation. So this is how we can use the method of completing the square by using the identity a minus b whole square or a plus b whole square depending on the sign which is there in front of the x term. If it is negative, we use a minus b whole square. If it is positive, we use a plus b whole square. There is another method of doing the same question. Instead of multiplying the equation by 3 to make the x square term into a perfect square, we can divide the whole equation by 3 and then also our x square becomes a perfect square. Let's see how we can do it. Our equation was 3x square minus 5x plus 2, and since the x term was not a perfect square, we can divide the whole equation by 3, which will give us x square minus 5 by 3x plus 2 by 3 equal to 0, which is equivalent to the previous equation and whose solution will be same as the solution of the given equation. Now proceeding in the same fashion, what we do is we have a as x, 2 into x into what should be taken so that the value doesn't change, that is 5 by 3, and that can be done by simply dividing 5 by 3x by 2x. X gets cancelled and we are left with 5 by 6. So our b is 5 by 6. We can add the square of it and subtract the square of it so that the value of the equation doesn't change and get the perfect square. This gives us x minus 5 by 6 whole square minus 25 by 36 plus 2 by 3 equal to 0. Solving this further, we get x minus 5 by 6 whole square minus 1 by 36 equal to 0, or x minus 5 by 6 whole square equal to 1 by 36. This gives us x minus 5 by 6 equal to under root of 1 by 36. So x minus 5 by 6 equal to plus 1 by 6 and x minus 5 by 6 equal to minus 1 by 6. We can solve further and find the values of x.